This is a video on surface area. The question states, find the surface area of the torus given by r of uv is equal to 3 plus 2 cosine v times the cosine of u, I, plus 3 plus 2 cosine v times the sine of u, j, plus 2 sine of v, k, and u is between 0 and 2 pi, and v is also between 0 and 2 pi. So we need to find the surface area, and the surface area is defined by the double integral over the region of the magnitude of RU cross RV dA. So let's find RU and RV. For RU, we take the partial derivative of R with respect to U, so we get 3 plus 2 cosine V, that's treated as a constant. The derivative of the cosine of U is negative the sine of U, times I, and then plus, here's the 3 plus 2 cosine of v again, and the derivative of the sine of u is the cosine of u times j, and there's no u's in 2 sine of v, so that becomes 0. So the k component is plus 0k. So now let's find the partial derivative of r with respect to v. So for rv, we take the partial derivative. The derivative of 3 plus 2 cosine of v is negative 2 sine of v, and then times cosine of u, I. Then we have, again, negative 2 sine of v times sine of u, j. And the derivative of 2 sine of v is 2 cosine of v. Then we have times k. So we now have r sub u and r sub v. We need to find the magnitude of the cross product of RU and RV. So the cross product is the determinant of the matrix I, J, K, and then we have negative 3 plus 2 cosine V times sine of U. We have 3 plus 2 cosine V times cosine U, and 0 for the K. Then we have negative 2 sine of V cosine U. Then we have negative 2 sine of V sine of U. And finally, we get 2 cosine v. So we take this cross product. So for the I component, we multiply 3 plus 2 cosine v times cosine u by 2 cosine v, and then subtract 0. And that's just 3 plus 2 cosine v times 2 cosine u cosine v, and then times I. For the j component, I subtract. Then I have a negative, so minus a minus is a plus. And then 3 plus 2 cosine v sine of u times 2 cosine v, and then minus 0. And for the k component, I did some simplifying. I multiplied the negative 3 plus 2 cosine of v times sine of u by negative 2 sine of v times sine of u, and subtracted the 3 plus 2 cosine v cosine u times negative 2 sine v times cosine u. And I simplified a bit, and what I got was the 3 plus 2 cosine v, that occurred in both, and then 2 sine of v. And that has to do with the fact that 2 sine of v times sine squared of u plus 2 sine of v times cosine squared of u, the sine squareds and the cosine squareds drop out and become a 1, and that just gives you the 2 sine of v times k. So at this point, we need to find the magnitude of RU cross RV. And remember, the magnitude is the square root of the sum of the squares of the components. So first thing, I can factor out a 3 plus 2 cosine v, and I'm left with 4 cosine squared u cosine squared v plus 4 sine squared u cosine squared v, and that just becomes 4 cosine squared v, and then I add 4 sine squared v, and I just get 4 for that part. So we just have 4 times 3 plus 2 cosine v, which is 12 plus 8 cosine of v. So now I'm ready to integrate. So recall that the surface area is the double integral over the region of the RU cross RV in magnitude dA. So we take the double integral. U goes from 0 to 2 pi. V goes from 0 to 2 pi also, of the 12 plus 8 cosine V dV du. And when I double integrate that, 8 cosine V, its integral is 8 sine of V, and we're going from 0 to 2 pi, so it just zeroes out. So we're just double integrating 12. So we get 12 times 2 pi times 2 pi, and that's 48 pi squared. So I can conclude that the surface area of this torus is equal to 48 pi squared. And I'm done with the problem.